Hari Om. In this part, we discuss the orbital velocity of the satellite. On what are factors does that depend? Now here, this is Earth, and a satellite of mass m is orbiting around the Earth in an orbit of radius r with a definite velocity v. So here I take VO as the orbital velocity. Okay. So this satellite is now moving around the Earth with a definite velocity, that is VO. Now from the condition for obtaining the satellite motion, we understood that the centrifugal force experienced by the satellite, so as it moves around like this will be experiencing a force outward and there will be an attractive force inward. So the centrifugal force experienced by the satellite must be balancing with the gravitational force of attraction between Earth and the satellite. So, centrifugal force experienced by the satellite, mass of satellite into orbital speed square divided by radius of the orbit. This is the equation for centrifugal force. This force is balanced by gravitational force of attraction between Earth and the satellite at distance r square. Now this is the condition for obtaining satellite motion. Now from that condition, we can obtain that small m and small m cancel, r and r cancels, and from this one you get VO equal to root of GME by small r. See, everything inside the root. Everything inside the root. Now from this particular equation you can understand that orbital speed remains constant for the given satellite, but it depends on what you say, the radius of the orbit. So for a given satellite, orbital speed remains constant. Another thing to be noted is that the orbital speed of the satellite is not depending on the mass of the satellite. Not depending on mass of the satellite, but it depends on mass of the planet around which it is moving. Now you can have some variations of this equation. Let us say that VO will be equal to root of G into ME by RE plus H. From the figure, small r will be equal to, this small r will be equal to, this is RE, radius of Earth, plus height from the ground. So RE plus H. H is nothing but the height to the satellite from the surface of Earth. Okay? Now, this is another way of writing. And you can relate this with small g, that is the acceleration due to gravity, that VO. So this is our basic form, and on which we are making all the adjustments. VO will be equal to root of small g into RE square divided by RE plus H. This is another way of writing, because I have replaced this GME with a small g. Thus from the equation, small g equal to capital G into ME divided by RE square. So that small g into re square will be equal to capital G into me. This is taken over here. So understood? It's a very simple derivation, but you have to remember all these things. Now, I take a special case over here. That is, suppose the satellite is moving close to the surface of the Earth. Satellite moving close to the surface of the Earth, that doesn't mean that you can touch the satellite from the ground. No. When I say it is moving close to the surface of the Earth, it refers to, that is, the closeness is taken like this, the height to the satellite and the radius of the Earth. Suppose this h is very small compared to RE, then we can say it is moving close to the Earth. Okay? Because RE, the value of RE is 6,400 kilometers. Remember all this always. So compared to 6,400 kilometers, if I take this as 100 meter or 500 meter, it is close to. Okay? 500, say 1 kilometer or 2 kilometer, 10 kilometers, all these are what? H very small compared to RE. Now such a height, if it is considered, from this equation what you get? If H is very small compared to RE plus H remains as RE itself. That is, RE plus H will be almost equal to RE itself. Then the formula will be VO. From here you get root of GME by RE. And from this you get VO equal to root of small g into RE. These are the special cases there. The satellite is moving close to the surface of the Earth. Only there you will be using this. Now from these two equations it is very clear that if that special case is taken, you will be getting a constant value for the orbital speed. Because capital G, ME and RE, all these are constant. Here also. And you can see the value, this value will be 8 kilometer per second distance. You can substitute the values and see the value of VO according to this equation will be 8 kilometer per second. So these are the things relating to orbital velocity. So remember the derivation. Centrifugal force balances with the gravitational force. From there you get this case, and these two equations are the special case where the satellite is moving close to the surface of the Earth.